Today we're working on notes 2.8, graphing systems of inequalities. So just like when we graph lines, we can also graph inequalities. We're still going to use the slope and the y-intercept, but there are a couple extra things we have to do when we graph inequalities. So one of the things is whether it's solid or dashed line. So if you have less than or equal to or greater than or equal to, it's going to be a nice solid line. If it's less than or greater than, then it's going to be dashed. Now this works whether it's a linear function or a quadratic. It's the same concept or absolute value. Some are solid, some are dashed. It depends on the inequality symbol. And then we're also going to be working and having to shade. So really, again, this depends on the way the inequality tip faces, and we'll go over this more. So like if you have y is less than, then you're going to shade below. If y is greater than, then you would shade above. Because you have infinite solutions. There's not just one solution. And then I'm also going to talk to you about you can use a test point to figure out where you shade. So that would be you'd pick a point either above or below. If it's a true, you shade there. If it's false, you shade opposite. But we'll talk about that. So when you're graphing a systems of inequalities, your solution is the overlapping shaded area. So when you do this, you're going to want to use probably like a pencil or a pen, or a pencil and then a highlighter, but you want to be able to determine the overlapping region. So we're going to graph these two lines. So y is greater than 3x plus 1, so I'm going to graph that. So the slope would be 3, right? The y-intercept would be 1, so it's been shifted up 1. And your slope is up 3. 1, 2, 3 over 1. Up 3 over 1. Down 3 over 1. Down 3 over 1. And it's greater than, so it's going to be a dashed line. So I have to figure out where do I shade. So y is greater than. So where are the points greater than that line? So one of the easiest ways is to do this is go to the y-intercept. So that green dot. Where are the points greater than that? Are they above it or below it? Well, greater than or above it. So I would shade above. I'm not going to get all crazy and go shading everything yet. I'm going to wait until I get the overlapping region. Now, how do you use a test point? Well, so to use a test point, let's say we use 0, 0. That's an easy one. So you pick a point not on the line, plug it in. 0 is greater than 3 times 0 plus 1. Is 0 greater than 1? No, that's false. So 0, 0 is below the line, so I would shade above. So to use a test point, you just pick a point on one side of the line or the other. Most of the time you will be able to use 0, 0 unless the graph goes through the origin. So use 0, 0. It's very helpful. Or use 0, 1 depending on what the graph does. But like 99% of the time you will use 0, 0. If it's true, then shade on that side. If it's not, shade on the opposite side. So now this next graph, and I'm going to do in blue, is in standard form. So I'm going to subtract x. So my slope is -1, and it's been shifted up 3. So 1, 2, 3. My slope is -1, so down 1 over 1, down 1 over 1. And this one is also going to be dashed. And now it's less than. So again, go to the y-intercept. Go to that red dot. Where are the points less than that? That would be below it. And again, you could use a test point, right? If you wanted to, plug in 0, 0. Right? 0 is less than 3 minus 0. Is 0 less than 3? No. So, yes, it is. Whoops. What am I thinking? Yeah, it is below. So then you would shade below. So now, where's the overlapping region? This is where you can go crazy on your color. This is the overlapping region right in here, because it has red and green shading. So this is the overlapping region. That's your solution. Everything in that black shaded area. So just pick 2 points. I don't know, -3, 0, -5, 0. Any 2 points in that black area are a solution. Any point you pick in that black area would be a solution to your inequality. So when you're doing this, that region should stand out to me. So right now, if I held this up to anyone, that black would just catch their eye right away. And that's what it should be when I'm looking at your paper. I should be able to easily tell what is the overlapping region. Don't make me guess. I'm a very expensive guesser. So now if you look at example 2, same thing, linear function. So I'm going to go purple. So your slope is -1. It's been shifted up 5. So 1, 2, 3, 4, 5, and your slope is -1. Okay, and this one's going to be a solid line, right? Because it's greater than or equal to, so it's nice and solid. Up here, both of these were dashed, right? So now where do you shade? Again, you could use a test point, right? Plug in 0, 0. 0 is greater than -0 plus 5. Is 0 greater than 5? No, it's not. So then you would shade above. Because 0, 0 is below, and that was false.
Just a sec.
All right, here, next one, slope is 2. It's been shifted down 4. Up 2 over 1, up 2 over 1, up 2 over 1. And again, this one would be solid. All right, nice solid graph. And again, you could use a test point. I could use 0, 0 again. 0 is less than 0 minus 4. Is 0 less than -4? No, it's not. So then I would shade below, because 0 is above. So where's your overlapping region? Again, I shouldn't have to guess. Here's your overlapping region. So the solution is that black area. That's your solution. So pick a point. 7, 0, and 8, 0. Any point in that black area is a solution. So all the graphing we did in Unit 1, the difference here is you have to add solid or dash and then the shading. Other than that, it's the same concepts. So go ahead and flip your notes over. So now we have an absolute value in a line, but it's going to be the same concept, right? Absolute value, it's going to be nice solid V. The vertex has been shifted down 2. Right? Slope is 1, right? A is 1, so up 1 over 1, up 1 over 1. Right? Use the symmetry. Again, use a test point if you don't understand how to use the symbols. Greater than, again, the way I would do it is, where are the points greater than that? They're in here. So if you plugged in 0, 0, is 0 greater than -2? Yes, it is. So you would shade inside, like we already did. Okay, here it's linear. It's going to be solid. Your slope is 2. Your y-intercept is down 1. Up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Okay, again, test point, 0, 0. Is 0 less than 0 minus 1? No, it's not. So you shade below. So your overlapping shaded region is right there. So pick 2 points. I don't know, 1, 2, 3, 1, 2, 3, 2, and 1, 2, 3, 4, 1, 2, 3. I don't know, any 2 points would do. There's an infinite amount of solutions. And again, why are those 2 points solutions that I wrote in black? Because they're in the black shaded region. That's the solution of the inequality, the overlapping region. Example 4. So now we have a line and a quadratic. So graphing the line, right here, your slope is 0. Your y-intercept is -1. So it's going to be a dashed horizontal line. So where are the points less than that? That would be below it. Okay. Now we got a quadratic. Vertex has been shifted left 1 and up 1. A is 1, so we can use our pattern. So 1, 3, 5, over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, over 1, up 3. And it's a nice, solid parabola. Now, where do we shade? Where are the points greater than? Again, I always like to go to the y-intercept. Why? Because almost every time I'm going to give you the y-intercept, or you're going to figure it out. So where are the points greater than that point? They would be above it. So is there a solution? No. This has no solution because there's no overlapping region. So there's no point that makes both inequalities true. So there's no points to write there. And that does happen. They have to overlap to have a solution. Okay, and the last 3 here. Now, again, to have a solution, in this case, all 3 regions are going to overlap. If they don't, then there's not a solution. So we'll save the exponential right now. Let's do the lines. So this is a line that has a slope of 1, and it's been shifted down 1. So the slope is 1, and it's going to be nice, solid line, and it's less than, so we're going to shade below it. Okay, x is greater than -1, so that's going to be a vertical line. Oops, it's going to be a dashed vertical line at -1. And where are the points greater than? That's going to be to the right. Okay, so far we do have an overlapping region. We'll see about the exponential now. So y is less than 2 to the x. So remember the key point is 0, 1. And it's going to be dashed. So 0, 1 is here. Remember, little table. We've done this a few times. -1, 0, and 1. 1/2, 1, and 2. And it's less than, so we're going to shade below. So eventually we're going to get an overlapping region if I kept shading the blue. Right? Eventually this here would be your overlapping region. Because the blue just keeps going. So there is a solution. So I don't know, let's say 3, -1, 5, -2. any of those would be solution. Anything in the black region is a solution. Again, understanding that this blue keeps going on forever. It'll eventually cover that whole area. So when you're graphing inequalities, right, understanding that you're going to have solid or dashed, that's looking at the symbol. If the bar underneath it's solid, if it's not, dashed. And then shading, either using a test point, which most of the time you can use 0, 0, like we were doing on the front side of the notes, or using the inequality symbol, less than, greater than. Understanding less than usually means below, greater than is above. If not, use a test point. Make sure when you're done filling out these notes that you answer your essential question as you're writing your summary.